Hello everyone, this is Deepak Joshi, and today we are back with another problem statement from LeetCode, that is search in a 2D matrix. This problem statement states that what we need to do is we need to find out whether the given target is there in the matrix or not. And how we are going to approach that is very simple for the brute force, for the optimized one. But for the better optimized solution, we'll have to look into some aspects of the metrics. Okay. Now, this is not a general any general metrics. It has some criterias, like it is sorted row wise. Let me take you to an example. Here is an example mentioning 1 3 uh  5 7 10 11 16 20 23 30 34 60. If you observe it carefully, it is sorted row wise, means 1357 is sorted in non-decreasing or in increasing order, and similarly 10 11 16 20 second row, third row, all are sorted, and the last element of one row is smaller than the first element of the next row. What do I mean by this is 7 is less than 10, similarly 20 is less than 23. This is how the elements are arranged in the matrix, and we need to utilize this as well to figure out whether target exists in the given matrix or not. First, initial brute force approach is simply using two for loops and figuring out whether the target exists in the matrix or not. And how we generally do that is figuring out the rows of the matrix. Let me check while typing my. Okay, yes, matrix dot size. That is how we calculate the rows, and how we calculate the size columns is by not by doing this, by simply doing this. Okay, and what we need to do is simply iterate over all the rows first, and then through all the column first. Okay, and do a j plus plus. Here we are going to check for each element whether the matrix of I comma j is equals to target or not. If yes, that means if this particular condition is true, means if this particular whole condition will true, then only if the if case is going to be run, and we are going to simply return true, else we are going to return false. I have this so much of confidence on this particular piece of code that I can directly click. I'm sorry, I have shown you a song, you can go through it. Okay. Yes. I have so much confidence on this particular solution that I can click submit button directly, and it is going to show me a TLE. But to check it, like whether it is syntactically wrong, I should click on uh, run test. Yes, and yeah, definitely I was wrong because syntax errors are very common. Now I think it should work fine. Yes, it. If I click on submit, there is no sense of clicking on submit. It is O of n square solution, and it is submitted. Cool. If it works, it works. Okay, let me check what's the time complexity mentioned here. No time complexity mentioned, but the constraints are there that it is okay. Okay. No issues, no issues. What's the target? There is no constraint for target. Okay, 10 to the power 4, and here it is. Okay. So basically, yes, it works on O of n square, but for this particular solution, we have not utilized the sorted thing, that all the rows are sorted, and the last element in the particular row is smaller than the next element, is smaller than the first element of the next row. Uh, next, what optimized solution I'm able to think of is, let us use that and then try to figure out. Okay. Let me take this particular example. There's no small example. Let me. I do not want to write the complete matrix, but anyhow, I have to write the complete matrix. So just let us write. Go with the flow. Sometimes we have to go with the flow. It's all in our brain. Okay. Now, let's say the target is 13, 13. 13 तो उसमें है ही नहीं. So what we can say do is, let's say the target is 11. What I'm going to do is I'm going to compare the first index of the row and the last index of the row with the target, like whether first index is smaller than the target and the last index is greater than the target. If that is equal, that is the case, less than equal to or greater than equal to, then only I'm going to iterate this particular row. Okay. Otherwise, what I'm going to do is I'm going to move to the next row. This is my strategy for this particular approach. What will be the time complexity here, Deepak? The time complexity here involved will be, we are going to iterate all the rows. Yes. No. No, not at all. We are not going to iterate all the rows. Instead, we are going to iterate. Yes, we are going to iterate all the rows, but not all the columns. So the time complexity will be O of n into that particular column's element. Simple. So we have reduced the time complexity from O of n squared to O of n into the number of columns in that particular. That becomes constant. Okay. Now, how we are going to code this particular solution? As very simple, let us calculate the rows. Rows will be matrix dot size. Yes, and how we are going to calculate the column is by matrix of I comma size, Deepak. Yes, and simply we are going to iterate from rows. Yes, we have iterated all the rows using this, and then we are going to check whether the matrix of I comma 0 means the first element. Okay, we are comparing the first element is is less than equal to target, and last element. What do I mean by first element? First element of that particular row. That means if we have to find out 13, let's say it is not there, but let's say light. Okay, okay. Let me close this thing. Yes. Um, yes. Sometimes it happens. Okay. So basically, let's say we have to figure out this particular three in this particular matrix, whether the three is there or not. How we are going to approach that? We are going to first compare the zeroth element or the first element and the last element, that is 7. Is 3 is like greater than equal to 1? Yes. Is 3 is less than equal to 7? Then only we are going to iterate the particular row. So we are going to check the same. Like first element is less than equal to, is less than equal to what? Okay. I need to do one thing. My Wi-Fi has been switched off. Okay. Yes. So what I'm going to do is I'm going to connect my phone. Let me. Yes. I think it is going to work now. Okay. So matrix of I comma 0 should be less than equal to target, and matrix of what? Matrix of I comma last element of the row, that is column minus 1, should be greater than equal to target. If that is the case, then only I'm going to iterate what? I'm going to iterate the complete row, this particular row 1357, and then compare each element with the target. This can be done using this method, this for loop method. Yes, but instead of doing that, what I'm thinking is we can use binary search, as it is a sorted array. So what we are going to pass in this particular binary search is matrix of I, the array, and the target that we need to find. Yes, if that works, it is going to return, else we are going to return false anyways. Now let us implement this particular binary search function. It should be the private method of the class solution, and it should return a boolean instead. What I think should be correct for this. Bool, and okay, I was wrong. I just should write okay, and it is going to take a vector of int that will be, let us take it by reference, no issues with that, call it nums, and it is going to take target. लगभग लगभग सभी को बाइनरी सर्च लगाना आता है, नहीं आता हम देखेंगे. Okay, how we are going to figure out binary search is simply, uh, let us calculate the size of this particular nums array, that is by this method. uh, we have to initialize two things. The first thing is the low, which will start from 0, and the high, that will start from nums minus 1, that is nums dot size minus 1 or n minus 1. We are going to iterate this particular we are going to iterate all over the indexes of this particular array until our low is less than equal to high. Simple, as simple as that. We are going to calculate the mid. How we are going to do that? Simple, high plus low divided by 2. There is another method taught by Love. I like that. I should use that, but I'm not using that right now because it is not that much big array. You can have a look at it. Okay. Yes, high plus low divided by 2. And then we are going to simply check whether the norms of mid is equals to target or not. If that is the case, we are going to return true. Else, if we are going to check target is greater than nums of mid or not, if target is greater than nums of mid, what we need to do is we need to move our low pointer from low to mid plus 1. Else we are going to move our high pointer to mid minus 1. As simple as that. I think this should work. If somehow we manage to get out of the while loop, we are going to return false because we have not returned true. That means we were not able to find out the array. Were not able to find out the element in the array. Let us check for any syntax error. There are a lot of syntax error. It says there is no will. It should be while. Okay, let's see. Okay, it says there is no matrix of I comma size. Okay, it should be matrix of 0 comma size. Oh, what's next? It says accepted. I should click on submit and it should get submitted. So this was our second approach, uh, which was based on this particular thing that we are going to have, and we are going to have some sort of idea regarding that the given matrix is sorted or sorted. But now what we are going to utilize now is, what if let's say we were able to convert this 2D matrix. Let me erase this particular thing. We were able to convert this particular 2D matrix from 2D matrix to a linear array: 1 3 5 7 10 11 1 6 2 0 2 3 3 0 3 4 6 0. Then we will be easily able to figure out the target is there or not in login time, in login time complexity. Very easy to do that, like, but for that, to convert this 2D matrix to a 1D matrix is going to be O of n squared time complexity. That will be probably more than our brute force approach time complexity, so we are not going to adapt that particular solution. But somehow, if we should be able to manage a imaginary 1D array which will reference to the matrix original elements. What do I mentioned is, let us do not have the exact 1D array, but what we are going to have is the imaginary 1D array that will reference to the matrix elements. Okay, how do I came to this particular solution? What I know is any particular row is actually what? Like, I can explain you in a very easy manner. Let me just try. How can I explain that to you? Let's say I have this particular thing called an index. Let's say I have this index. uh let's say this particular 3 is at index 1, or let us increase that index: 1 2 3 4 4. So this particular 10 is at index, okay, I'm going to explain you, is at index 5 4, right? So the row for this in the matrix, or I should write row. The row for this particular index will be 4 divided by size or number of rows. Number of rows. Simple. Let me explain you what are the number of rows. We are aware about how many number of rows are there. Like, there are 0, 1, 2, 3. Three number of rows, right? So what will be the row number for this? 4 divided by 3 is 1. Great. Okay, we are right. And for column, what we are going to do is 4 percentage m, that is number of rows again. Okay, I am sorry, it is not number of rows, it is number of columns. Why I did wrote 3 instead? Okay, it is number of columns. Okay. Okay, how number of columns are 3? Because we counted it from 1 2 3 4. Okay, so it should be 4. Yes, 4 divided by 4 is 1. Okay. Right. All right. So 4 divided by number of columns is the row of that particular index, and if we are going to find out the column, that is using this only, like 4 percentage number of columns, 4 percentage 4, that will come out to be 0. That means the 2D array index for 10 is what a row number is 1 and column number is, oh, I'm sorry, I did something wrong, I think, because the row number should be 0 and the column number should be, yeah, like I I should, because row number should be what, okay, was 0 1, I am just checking out 0 1 2 3 4, this is the index of this particular 10 4. Then I was checking out row, it comes out to be 1. Okay, all right, column is 4 percentage 4, that is 0. Okay, I think there is something wrong that is needed to be taken care of, because it should have not worked this way, because I think no, no, row number is actually the current index of 10 is 0 comma 1, right? This is the correct index for 10. Okay. Actually, I was thinking of 3. I'm sorry. 10. It is 10, na? So it is right. 1 comma 0, because 10 is at row number 1 and index 0. I hope you got it right. Let me dry run it on some other index. Let us say 20. This particular 20. So 20 is at an index of what? Let me count. 0 1 2 3 4 5 6 7. So it is at index of 7. So how we are going to calculate row? Row is calculated by 7. Uh, I'm sorry, divided by number of columns. That is 7 divided by 4, comes out to be 1. Simple. Okay, great. And then I have to calculate columns. That is 7 percentage 4, comes out to be 3. Yes, so I was right. That means the 2D array index for 20 is what? 20 is 1 comma 1 comma 3, and that is actually right, because 20 is at first row and index is column number is 1 0 1 2 3. Bilkul sahi. So we have managed to make an imaginary 1D array and referenced it to 2D metrics. Now we are going to apply simple binary search on that particular 1D array. Right? All right. A heavy jugaad that we have managed to understand. Simply calculating the row and simply calculating the column. I hope this time I have not written rows and column. Instead, I have written n and m, so it is clear to you. Okay, for applying binary search, we are going to have our low and our high. High will be m minus 1. And simply we are going to do while low is less than equal to high, going to calculate mid. That will be calculated using low plus high, but feel free to use another method of using mid. And then we are going to calculate the row. How we are going to calculate the row? Simple, as mid is the index, total number of column, that is m. And then we are going to calculate the column as well for this particular mid index, that is by this method. And then we are going to check, like for matrix of row and column, if it is equal to target, we are going to return true. Else if matrix of row comma column is less than target, simple, is less than target, then we are going to return, or not return, then we are going to make our update our low to mid plus 1. I'm sorry. And else we are going to update our high to mid minus 1. And if we were not able to return true, then that means there is something fishy, and we were not able to find out that target is there in the matrix. So we are going to return false. Accepted. We should submit it, and we were able to find out the this thing in okay 3 expected as true. That means we have done something wrong. Deepak, you have to take care of it, and I'll take care of it definitely. Okay. N is matrix of size. What is the input? 1 comma 3, and हमने 3 check करना था. Okay. It says okay. Let me take a look at it. Matrix dot size, matrix of 0, low 0, high m minus 1. Low is great less than equal to high m. Mid calculate किया. Row निकाला, that is mid divided by m. Yes, and then column निकाला, that is mid percentage m. यहाँ तक we are right. Then calculated that mid of row comma column should be equal to target. If that is the case, simply return true. Else if matrix of row comma column is less than target, low becomes mid plus 1. All right. And if that is not the case, simply put high. Okay. Okay. Because here is the case, like high equals to mid minus one. What I have done is, like, I have made m minus one. No, the actual size of the array or the referenced array will be m into n, because we have lineared this particular matrix, so the size of the 1D array will be 4 into 3, that is 12. Row number into column number minus 1. Okay, the last index will be 11th. That is why it should be n minus 1. Okay, now this time it is going to submit successfully, and I hope you guys were able to understand it. uh, and we'll see you in some other video. Bye bye, take care.